Hey everybody, my name is Toby Knaup. I'm co-founder and CTO of Mesosphere. And I would like to talk about one of our customer use cases. This customer, Royal Caribbean, they're running our product, DCOS, both on AWS and on their cruise ships out on the ocean. So this is me, kind of an old photo. This is what I look like right now. I want to talk about a brief history of our company and our technology. So Mesosphere, what we do, our product is called DCOS. It's actually based on an open source technology called Apache Mesos. Apache Mesos was created by my co-founder Ben Heintman at UC Berkeley in 2009. And it was really the first open source production-grade container management system. So container management and cluster management originally started at Google and Facebook. They were the first companies to run their infrastructure that way. They built internal systems, proprietary systems to do that. And Mesos really was based around the same ideas, but it was the first open source system that was freely available. The companies that adopted Apache Mesos were Twitter and Airbnb. I worked at Airbnb. My two co-founders worked at Twitter. We set up the infrastructure there, which is based on Apache Mesos. We then started Mesosphere in 2013 to take this open source technology, create a product around it. That product is called DCOS. And today we have over 125 customers worldwide that are using the software. So what Mesosphere DCOS really enables is modern data-driven applications. So data-driven applications meaning customers are collecting data in real time from their users on a website, from IoT devices, from cars, or from cruise ship customers that are wearing wristbands as they're moving around the ship. So modern data-driven applications. And so modern data-driven applications require a lot of infrastructure. You need to ingest data in real time. You need to process and analyze it in real time. You need to store it in a time series database. And then you need to build applications that are reading that data and are reacting to it as it changes and serving it back to the user. So DCOS is a platform that allows you to run all of the infrastructure components that you need to build a modern data-driven application on a single platform. DCOS runs on any type of infrastructure. So you can run it on AWS. You can run it on any other public cloud provider. You can also run it on physical machines or on a private cloud, and now even on cruise ships. At a high level, the components in DCOS is Apache Mesos. That's the core of it. That's the resource manager. It's what enables all of these different types of applications to run on top. What Mesos provides is it takes all the machines that you have deployed in your AWS account or in your private cloud or data center, puts them together into what we call a resource pool. So they get thrown in together into a pool, and then that pool is exposed to the different types of applications. So any workload you run on DCOS runs on the same pool of machines. That allows us to drive up your utilization dramatically and also reschedule applications easily onto other machines, should you have a hardware failure or should your application crash. So other pieces that are built into DCOS, application-aware scheduling. So there's container orchestration with tools like Kubernetes and Docker Swarm and Marathon, which is a container scheduler that we built. But if you're running stateful applications, which you need for modern data-driven applications, databases like Cassandra, message queues like Kafka, they need a different kind of orchestration. They're stateful, so you need to really take care of where's the data, how do you manage that. So DCOS provides application-aware scheduling. Provides security and compliance, really important for enterprise environments. Multi-tenancy, so you can actually run multiple workloads, multiple business units on the same platform. And then all the management and operations tools that you need to run a production-grade platform. On top of DCOS, you can run a range of workloads. So I mentioned container orchestration. That's a critical workload for us. Microservice container orchestration. Marathon was the first production-grade container orchestrator that was out there. It's a product, open source project built by Mesosphere. We also support Kubernetes on top of DCOS, so you can choose which orchestrator you would like. And then there's a whole range of other workloads. Dev tools, CI/CD, Jenkins, and GitLab, and others are supported. And then there's over 100 data services, so databases, message queues, big data tools, machine learning tools, the leading open source and commercial products. So open source databases like Cassandra, their commercial variants like DataStax Enterprise, or open source Kafka, and then Confluent Kafka, the enterprise version of that. So over 100 of these services that you can run on DCOS. So I mentioned DCOS takes all the machines and puts them together into a pool. And really, what you get is your cloud deployment or your data center now starts to look like a giant computer. And if you go to the dashboard of DCOS, this is what it looks like. It literally shows you one big pool. It doesn't show you individual machines. And so that gives us a lot of flexibility. And I always like to compare it to, if you were to run applications on your laptop the same way that we run them in a data center or cloud sometimes, you would start your browser and then a window would pop up and ask you on which CPU you want to run it, right? That's obviously not how it works. There's an operating system on the laptop that decides which CPU core to run it on. And so DCOS provides the equivalent of that at the cloud level or data center level. So it schedules whatever workloads you have onto the machines that have the right resources, the right hardware available for those workloads. The way you install these platform services, these workloads, so databases, machine learning tools, even Kubernetes, is from the DCOS catalog. So it's very similar to how you run AWS services from the AWS console. You have a catalog of all these workloads. If you accept the default configuration, you can literally start them with a single click of a button. But a lot of the parameters are also tunable, so you can decide what size cluster of any of those workloads you want, how much CPU memory and disk to allocate to them. So it's a real, really easy experience to get any of these data services running. So benefits. What are the outcomes of using DCOS? What are our customers seeing? And really, it's all about agility for a number of different personas. So for operators, by pooling these workloads together, you drive up your utilization, right? You no longer have all these VMs or physical machines that you're not utilizing. We actually bin pack multiple workloads onto the same physical or virtual machines to drive up your utilization. So you no longer have to keep track of all the different hardware configurations, whether those are virtual machines on a cloud or physical machines in a data center. Data center automation, so these workloads are actually automated to a very high degree. They install with a single click of a button. You can upgrade them with a click of a button or an API call, scale them up, scale them down. And it enables hybrid cloud, which is what I'm going to talk about for this ship-to-shore use case. For developers, container orchestration, I already talked about, continuous integration, continuous deployment. You can run Jenkins, GitLab, many other tools like that. And data services, this whole range of databases that developers can use. For data scientists, you can run a lot of big data tools on top of DCOS, Spark, Flink, TensorFlow, many others. So machine learning and fast data workloads as well. All right, so let's talk about this use case at Royal Caribbean. It's really interesting. So Royal Caribbean has a fleet of over 20 cruise ships, and their use case is they want to collect data as customers move around the ship and go on excursions. They want to collect that data to provide a more personalized experience for their customers. So customers are wearing wristbands, they're doing purchases on the ship, they're collecting all that data. Then they run marketing campaigns and things like that based on that data. Now, a cruise ship is out on the ocean, right? The way a cruise ship connects to the internet is via a satellite link. That satellite link has fairly low bandwidth. Actually, most of the bandwidth of that link is used by the customers checking Snapchat and so on. So it's a low bandwidth link. It's a high latency link. So for building a real-time application on the ship, it's not feasible to always send every request back to shore to a data center or a cloud. So they had to run part of their applications on every ship. So there's a mini data center on each ship that's running Kafka as a message queue and a number of microservices that are providing these personalized experiences on the ship. Now, Royal Caribbean is also an AWS customer, so they love AWS, they love the automation that the cloud provides. And they wanted that same experience on their ships, right? Ships are out in the ocean, you can't have a full operations team on every one of the 20 ships, that's not feasible. So they wanted a cloud-like experience on every ship, the same level of automation, the same level of fault tolerance and self-healing capabilities. So that's why they picked DCOS. It's one big reason. The other reason they picked DCOS is they wanted the same stack running on AWS and on the ships, the same way to deploy applications, to upgrade them, because some of the components are actually the same. So you can see Kafka running both on the ship and on shore. They're also running Cassandra. It's actually DataStax Enterprise that they're running as their distributed database, and a number of microservices, and Spark for doing analytics. So same deployment stack, same way to architect their applications. They don't have to build two different silos of tools for the ships and for AWS. DCOS gives them that abstraction on top of whatever the underlying infrastructure is, whether it's AWS or physical machines on the ship, so they can deploy applications the same way. This is a really good example of what I mentioned initially, a modern data-driven application, right? So if you look at the top of the slide here, the journey actually starts when the customer is still at home, booking the next cruise, researching the packages, researching what the options are, which excursions they can go on. So they start collecting data even there, and this goes obviously to the on-prem data center, the cloud data center, the onshore data center. So they're collecting some of the data there, and then as the customer gets ready to go on the cruise, some of that data actually needs to get synced to the ship, right? Which trips did this customer book, and so on. So they're using Kafka for that as a way to exchange data back and forth. So both the data that the customer generated onshore goes to the ship, and then while they're on the cruise, the location data where the customer is moving, which trips they're going on, gets then synced back to the AWS deployment again via Kafka, so they can also run analytics across multiple cruises, across multiple ships, and then use that to create compelling offers for their customers, right? To run campaigns, to create a customer 360 profile over multiple journeys that this customer went on. So, talked about modern data-driven applications. They require a lot of infrastructure, a message queue like Kafka, analytics engine like Spark, a distributed database like Cassandra, lots and lots of microservices. DCOS is really a great platform for running all of these components together on the same platform. And we talk a lot about microservice container orchestration. That's an important workload for us. What DCOS does is it also has data service orchestration built in. So there's actually what we call an application-aware scheduler. It's a piece of software that we create for each one of those workloads, for Kafka, Cassandra, and so on, that has all the operational logic of this service built in. So you no longer have to be an expert in each one of these technologies in order to deploy them. Think about it as a human operator and a run book that's basically stored as code that comes part of the package as you install it on DCOS. And so this level of automation, these software-defined runbooks and operators, that's what enables Royal Caribbean to have a cloud-like experience even out on the ocean on their cruise ships. So this is just one of the use cases that DCOS supports. I think it's a really fun one. It's a form of edge computing that you kind of don't expect when you hear it first. There's many other use cases across literally every industry vertical. A lot of IoT use cases for DCOS, connected car, financial industry. So to learn more, stop by our booth. Lots of folks there. And thank you for listening.